Everyone, today we're going to talk about distance formula and midpoints. And so this is lesson 1.3. Our objectives: find the distance between 2 points. We'll do this on a number line and the coordinate plane. And then we're also going to find the midpoint of a segment. So these will be two separate formulas we'll use. So the distance, that's our first thing we're going to work on. The distance between 2 points is the length of the segment between those 2 points. And so we'll go with distance formula on a number line. And the distance between 2 points is the absolute value of the difference between their coordinates. So it's, in this example, the distance of PQ is the absolute value of x2 minus x1. You can go x1 minus x2 as well, but it's the absolute value of that distance, so, or of that difference. So let's use the number line to find BE. So B, E are the coordinates we're going to want to use. So BE, again, it's the difference in those coordinates. So -6 minus E, its coordinate is 2, so -6 minus 2, what's that absolute value? -6 minus 2 is -8. So the distance between B and E is 8, of course, okay? Notice, guys, this is common that we've got to use parentheses when we're plugging in values, okay? So when I plugged in -6, when I plugged that in for x2, I used parentheses. When I plugged in +2 for x1, I use parentheses. They help us keep track of signs. So you should get comfortable doing that. AC. So we want to find the distance of AC. So that segment there. So AC equals the absolute value of, let's substitute A in, which is -7 minus C is -4. Again, I use parentheses when I substitute. So this becomes the absolute value of -7, -4. Double negatives become +4. So it's the absolute value of -3, which is 3. Guys, rather than use the formula as well, if you've got a number line and you can see both coordinates on the number line, guys, you can always count. Count the distance between A and C. 1, 2, okay, 3 units. So you can do that as well. If you're using this formula and you're like, well, I can see the distance. Well, yeah, certainly you can. Okay, the formula a little more helpful when we've got some coordinates that might be a lot further from each other. So that's our first page of notes here. Now we're going to do distance formula in the coordinate plane, and this is one where you can't count. Okay, in the coordinate plane, it's not so easy to just say, oh, that's 1 unit, 2 unit. You cannot do that. So we've got to use the formula. All right, and the distance formula for the coordinate plane is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So it's the difference in the x value squared plus the difference in the y value squared, and then you've got to take the square root of all of that. Okay, of course, x2, x1, guys, these x's and y's come from your coordinates, where the points are located. So find the distance on a coordinate plane. Find the distance between C, which is -4, -6, and D, 5, -1. So again, one of these points is going to be x1, y1. The other point is going to be x2, y2. It doesn't matter which one you label. Very similar to when we use linear equations in Algebra 1. Okay, but let's find the distance of that. So CD is, we're just using the formula. Okay, x2, 5 minus x1, -4 squared plus y2, -1 minus y1, -6 squared. So simplifying this becomes 5 plus 4, 9. So that becomes 9 squared plus -1, that becomes plus 6, that becomes 5 squared. 9 squared is 81, 5 squared is 25. So now we're taking a look at the square root of 106. And guys, you guys can use your calculators. The square root of 106 is approximately 10.3 if we round to 1 decimal place. And we can round to 1 decimal place unless it states otherwise, okay? So that's fine there. Alright. Let's go ahead and talk now about our next definition, which is midpoint. So the midpoint of a segment is the point halfway between the endpoints of a segment. So it's exactly halfway between our two endpoints, okay? And so again, we're going to do this on a number line, and then we'll do it again in the coordinate plane. So if AB has endpoints at x1 and x2 on a number line, then the midpoint MB, or the midpoint of AB has a coordinate of x1 plus x2 divided by 2. This is M, the midpoint. Okay, and you can see that over here. If we've got x1, x2, we add them together and divide by 2. That gives us our midpoint. So our next example is midpoint on a number line. Okay, Jacinta hangs a picture 15 inches from the left side of the wall. So 15 inches from the left side, so out there, I apologize, not out there. That's A, the picture's 15 inches away. And how far from the edge of the wall should she mark the location for the nail if the picture will hang on if the right edge is, I can't read, I'm getting mixed up here, I apologize. How far from the edge of the wall should she mark the location for the nail the picture will hang on if the right edge is 37.5 inches from the wall? So the setup here, that's 37.5 inches. Of course, we're going to put the nail at the midpoint. So there's the setup. Okay, apologize there. The ruler acts as our number line here, so the midpoint where the nail should go is you add the x coordinates together and divide by 2. So that is 26.25 inches is where she should mark to place the nail. Alright? And so midpoint formula in the coordinate plane, somewhat similar, okay? Really, you do the number line formula, you do it twice. You do it once for the x's, so to find the midpoint, again, it's going to be an x and a y coordinate. So to get the midpoint of the x's, you go x1 plus x2 and divide by 2. And then to get the midpoint of the y's, you go y1 plus y2 over 2. So you just got to apply midpoint formula to the x's and to the y's. Add them together and divide by 2. Alright? So find the coordinates of M, the midpoint, of ST for S is -6, 3. So that's x1, y1. And T10, let's go x1, x2, y2. So the midpoint, again, is x1, -6, plus x2, 1 over 2. And then for the y's, we go y2, or y1 plus y2 over 2. So add the x values together and divide by 2. So -6 plus 1. -6 plus 1 is -5. -5 over 2 is -2.5. For the x coordinate, 3 plus 0 is 3. 3 divided by 2 is 1.5. So that is the coordinates of M, -2.5, comma 1.5. Okay. So our next example is find a missing endpoint. So this is an interesting type of problem here, where you will be given the endpoints. Okay, you'll be given one endpoint, and you'll be given the midpoint, and you're going to be looking for the other endpoint, or vice versa. It really doesn't matter which endpoint you're given. They kind of set up the same way. So you can use these formulas. Personally, I just prefer to kind of set it up, and I'll show you how it goes. So find the coordinates of J if K is the midpoint. So K is our midpoint, and it's -1, 2 is our midpoint. Okay. Of JL, and L has coordinates 3, -5. So if you remember, midpoint comes from adding the x values together and dividing by 2. So -1 would be equal to the x value 3 plus the other x divided by 2. If you solve that equation, you're going to get the x coordinate of J. Okay. The y coordinate of our midpoint 2 comes from adding the y values together, which is -5 plus whatever the y value of J is divided by 2. Okay. Now solving both of these should give us the coordinates of J. So to solve this first one, let me come up here where I've got a little more room. -1 is equal to 3 plus x over 2. You multiply both sides by 2, so -2 equals 3 plus x. You get that -5 is the x coordinate, and for our y coordinate, the equation was 2 equals -5 plus y over 2. So multiply both sides by 2, and you get 4 equals -5 plus y. So you add 5 to both sides, and you get that y is equal to 9. So the missing endpoint, J, the x coordinate, was -5, and the y coordinate was 9. Okay. Similar type problem here for EG. The midpoint here is P, so you use the midpoint is -5, 10, and in the formula again for that, you add the x values together, so it'd be -8 plus x over 2, and then you add the y values together, so 6 plus y over 2. Okay. And so you set up the equations, see if you can't solve them. You should get that the missing endpoint G is at -2, 14. So if you struggle with that, if you struggle practicing that problem, then you'll probably want to see me tomorrow when we do one of these on the homework. Okay? Or maybe suggest that we do one of them on the homework together. Alright. And so one last type of problem we can do here with midpoints. We can find the measures of PQ if Q is the midpoint of PR. So we're told that Q is the midpoint. If Q is the midpoint, that means that PQ is congruent to QR. Their measures are the same. Again, that means that PQ is congruent to QR. So their measures are the same. So then we're able to say 9y minus 2 is equal to 14 plus 5y. And we can find y, alright, which we'll eventually be able to plug in and find the measure of PQ, which is what we were after. So subtract 5y, we get 4y minus 2 equals 14. Add 2, 4y equals 16. Divide by 4, and you get that y is equal to 4. Okay, so then to find the measure of PQ like we were asked, we plug in 9y minus 2, so y was 4. 9 times 4, 36 minus 2. You get that PQ is 34. Okay. The next problem you'll have to set up, or occasionally you might have to set up the number line, but that's how that type of problem will go. Your assignment, page 30, 1 through 12, all. Alright, so again, thanks for watching, and we'll do that assignment there in class, okay?